Hello everyone and welcome to this Microsoft Reactor workshop today. My name is Erika and I am the program manager at microsoftreactors.com. Today we are going to continue with the second episode of this mini-series, and in this session we will explain about troubleshooting and debugging Python on Kubernetes. But before I carry on, I just want to say a quick word about Microsoft Code of Conduct. We all come from a different background, but we are all here to learn. So please be aware of each other and please be welcoming to all points of views. Thank you. And now let me introduce you to our speaker today, Natan Yellin. Natan is a long-time open source contributor. He's a CEO of Robusta.dev, an open source platform for investigating and troubleshooting Kubernetes issues. Let me bring you here. Hey, Natan. Hey, how are you today?
I'm good. Thank you for having me back. It's a pleasure to be
here. It's great to have you back. I'm looking so much forward to today's session. It's been great last week. And today, during your hands-on demo, you are going to talk about troubleshooting tools in general and adjustments that need to be made for Kubernetes. Is that right?
Yes, that is. And I'll give a brief overview of what I'll be speaking about today. This is part 2, though, continuing part 1 from last time, about getting your Python applications up and running on Kubernetes. And we're going to assume that you have an application. We're going to focus on Python, but it applies to other languages as well. So we're going to assume that you have a Python application running on Kubernetes, and you start to have issues with that application. We'll look at what type of issues those are, and then how you can troubleshoot those. So let me share my screen.
That sounds fantastic to me. There you go. Sharing your screen. Thank you again for taking your time and being here with us. I'm going to put myself to the background now, and I will see you in about 45 minutes or so. And guys watching, please just go ahead and ask your questions in the chat. We'll keep an eye on it, and Natan will answer as fast as he can. So
I set the second screen, so I have one eye on my slides and one eye on the chat. So please go ahead and write stuff, and I'll respond as they go along. Okay, so we're going to look at really 3 different things. First of all, what are common problems that occur in Python applications? This is really in general, but we're all specifically going to look at it in the context of Python applications running in the cloud. 2, what tools can you use to troubleshoot those problems? And 3, given that you're running in Kubernetes, how do you have to adapt those tools, and what changes do you have to make to get them working on Kubernetes? A little bit about me. So I've been a Python developer and involved in open source since high school. Also done a lot of DevOps work and work in Kubernetes. I'm the founder of Robusta.dev, which in my unbiased opinion is the best way to monitor your Kubernetes cluster based on Prometheus. I do a lot of blogging. I've written some other open source tools, for example, the Profiler for Jupyter Notebook. So there's lots of other stuff out there. And hello to everyone joining in the chat. Hello, Liam. Hello, Newbie. Hello to the Robusta usuals, Kumar Anurang. Pleasure to see you, Artem, and everyone else. So let's jump right into it. So really, we're going to look at, there are 4 general types of issues that occur when you're running Python applications in the cloud. The first is high CPU. The second is memory leaks. The third are logical issues. And the fourth is high latency. And to the person who wrote in the chat, yes, I do read the chat, and I will try and answer questions. Now, for each of these issues, though, you can really divide up dealing with that issue into kind of 2 parts. First, and what's this the second here, is noticing the problem to begin with. So you might have high CPU. So how do you even notice that you have high CPU in your application? How do you even notice that there's a memory leak? Same for logical issues, high latency. How do you notice the problem to begin with? And then second, once you notice that there's a problem, how do you investigate and find the root cause and then go ahead and fix it? So for most of these issues, the way that you would notice the root cause is metrics. And metrics are really just a number that your application updates from time to time. And you can take that number and you can do various things on that. So in the case of CPU, this number would be what is your CPU usage? And that's a CPU metric that you can gather. In the case of memory, a metric would be, okay, how many megabytes is my application using right now? That's the metric. That's the number you're tracking. And you track this over time. So you can track a graph of that over time and so on. For logical issues, this really depends on your application. This could be the number of users who are connected This could be the number of transactions you did. But again, there are various numbers that you're going to want to use to try and track this. And if for the most part, what you're going to do is you're going to gather different metrics. And there are different solutions for that. I believe there's some Azure-specific solutions as well. One common solution for Prometheus, for Kubernetes is to use Prometheus. Prometheus is a time series database, so it gathers these metrics from your application. It gathers these metrics from the cluster, from the infrastructure, and then Prometheus will gather all these metrics, and you can view them over time. Once you have these metrics, then you can do one of two things. Either you set up an alert, so whenever one of these metrics goes over a certain amount, then an alert fires. For example, you can set up an alert so that whenever the CPU usage goes over 30%, then an alert fires. Whenever your application uses more than 1 gigabyte of memory, then an alert fires. Or whenever you have a logical issue and suddenly you're doing no transactions or there are no users connected for at least 5 minutes, then an alert fires. So given that number, you can set up alerts. That's the first thing you can do. And then you can also go into different systems, look at graphs of that. So there's Grafana, of course, which is very popular. And you have to define different dashboards. Robusta, which I work on, we try and just show you the right dashboards and the right graphs up front so we see what the issue is. And we'll try and show you the right graph without making you configure anything or go and find it. But there are various ways that you can graph those different issues. And most of this talk is going to focus on this area over here for finding the root cause. So I'm going to assume for most of this talk that you have some form of metric set up. You have some form of basic monitoring set up with alerts, or you can see graphs. So somehow you notice that there's one of these issues. You notice, okay, I have high CPU, or okay, my application's memory has doubled in the past 30 minutes and it still is going up, so there's some memory leak there. You notice the logical issue, oh, suddenly no users are connected to my application, or it's crashing all the time, or whatever. So you notice all those issues. And once you notice those issues, then you jump over here to finding the root cause, and that's what we're going to focus on. So 2 more things I just want to say about that. First, I touched on it, but for Kubernetes, the go-to stack that we see most often, that's really the most common, is to set up Prometheus, Alert Manager, and Grafana. And we also develop Robusta, which is a great add-on for that stack. And what that does is that gives you Prometheus, which gathers these different metrics and these different numbers like CPU usage, memory usage, and so on. Alert Manager can then do alerts when you have a specific thing that becomes an issue. For example, just based on the metrics, then the CPU is 30%. But is that good? Is that bad? So you can set alerts with Alert Manager, and then can build different dashboards and stuff with Grafana. And then what we add on with Robusta is we add on the investigation and troubleshooting issues, and we bundle with Robusta Prometheus and Alert Manager and Grafana, so you can do an all-in-one install and get everything. So that's one thing that you have to have set up, not to investigate the root cause, but to kind of notice that these problems in your application exist to begin with. And the other thing I'll say before we really dive into this area is just about high latency and tracing. So I want to emphasize that there's a difference here between high latency and high CPU. Let's say you go into a restaurant and that restaurant is really, really busy. That's high CPU. That's not a fundamental problem in and of itself. If the restaurant reaches full capacity, then you're at full CPU and maybe you need to like double the restaurant to make a new one, or you need to scale up the restaurant in Kubernetes terms. But that's not a problem in and of itself that there's high CPU. It just means that things are busy and happening. On the other hand, high latency means you come to the restaurant, you order, and you get your order back, and they bring you your food in 2 hours. So that's fundamentally bad. For the most part, there are cases where you don't care about high latency. For example, if you order from the grocery store or you order from Amazon, they deliver it to you tomorrow. In many cases, that's fine. So that's really high latency, but you don't care about it because you don't need it right away. So these 2 issues, high CPU and high latency, can be different, and you can troubleshoot them in different ways. Today, we're going to focus on high CPU. So your application is using live CPU, so it's very wasteful in terms of resources, perhaps, or perhaps you're running out of resources, CPUs that you can use in your cloud, in your cluster. So you want to reduce the CPU somehow. You want to see why that's happening. We're not focusing today on high latency and tracing, which are really a slightly different but related problem. So with that said, let's jump into each one of these issues one at a time. And we're going to look at why the issue happens, look at an example of that issue, and then how you can troubleshoot those for Python in general and on Kubernetes specifically. Before I go on, if there are any questions in the chat, then now is the time to write that, and I'll answer any questions about this intro. Okay, so let's move on. One other thing I want to add about fixing these problems is there are 3 general strategies for how you fix these issues, whether it's high CPU or memory leaks, sometimes even logical issues. The first solution is you just do nothing. Sometimes the issue isn't very acute. The second solution is throw more resources at your application. So maybe you have high CPU and you just allocate more CPUs, and then that's okay. Maybe you have a memory leak and your pod or your application is crashing and running out of memory once an hour, and you just say, okay, well, that's fine. Or I'll double the memory, so now it runs out of memory and crashes every 2 hours, but that's not actually an urgent issue that's affecting any customers because it crashes and then Kubernetes brings it back up. And then the third way that you can fix these issues is by actually fixing them and doing in-depth troubleshooting and solving the root cause. And there again, you're using all of these tools. So that's what we're focusing on here. Okay, so issue number 1 is memory leaks. And the obvious question you have to ask is, how can you have memory leaks in a garbage collected language like Python? Python frees memory automatically, so how can you have a memory leak if Python is garbage collected? And the answer is it's actually very simple to have a memory leak in Python. Here's kind of a silly example. I have here an array called event log, list in Python terms. And essentially, I keep on adding stuff to that event log. I'm reading some event, I'm handling it, and at the end, I'm storing in this list. So this list keeps on getting bigger and bigger and bigger. And because this list keeps on expanding, then the memory here just keeps on expanding. And I never take items out of the list. So this will always get bigger. Now, I'm going to put up another example that's a little bit more complex. It's a variation on this to show how you can have a memory leak that isn't as obvious. So let me bring that up now. Here's an example, and I'll take a moment. I'll let you guys look at this example, and I want to see if anyone can see what the exact bug is here. And this will either be extremely obvious to you right away, or you won't see it. And I want to just say a little bit about the way this is being used. There's a coffee cup here, coffee machine here, and it has 2 variables, bean type and usage log. And the way that I'm using this in my code is I'm creating a whole bunch of coffee machines, and I use them a bit, and then I delete them. So these coffee machines, the way I intended to use them is I intended to allocate a coffee machine, use it for a bit, and then delete it. So obviously here I have some usage log, but I intend for this to be deleted every time because I use the coffee machine a bit, and then I delete the coffee machine, like I get rid of it, and then it gets garbage collected, and then I create a new coffee machine. So I see one comment in the chat that usage log keeps appending without destructor. That's true, but let me ask something different. Here I'm accessing self.usage log. So for self.usage log, why isn't that a member variable? Like, why isn't this usage log per each individual instance of the coffee machine? And the answer is Python just doesn't work like that. It's something that I see people mess up with. I've actually written a blog post because I've seen it one too many times. Usage log here is a class variable, so it's shared by all instances of the coffee machine. And on the other hand, like what I probably meant to do is just to set this in the init function, or to set this in a different place, so that would be for each individual coffee machine and not be a class member. But this is an example, really. Maybe it's also an example that's a little trivial, but this is an example of how you can have an application which you wrote in Python, which is doing something that looks like it's approximately right, and you're leaking memory, and your memory usage keeps on going up. And sometimes this type of issue can be hard to track down in a big code base. Obviously, in this example, whereas someone mentioned in the comment, I wrote oops over here, I mean, it's easy to see that this is the memory leak, and that usage log keeps on increasing in memory. But in large code bases, you have lots of code, thousands of files. It can be a little hard to actually find what the memory leak is. So let's look at some tools for how you can debug memory leaks. And we're going to look at 3 different approaches. So the first approach is essentially you want to say, okay, what line of code allocated the memory? Now, if I go back to this example, then it would be this line. So I'd be able to point at this line. I'd be able to say on this line, I did something that allocated memory, and that memory was never freed. So in Python, you'd use a library called Tracemalloc that's built into the standard library, I believe. And you just run tracemalloc.start at the beginning of your code. And at some point later in time, you run snapshot equals Tracemalloc.takeSnapshot. And now essentially you're generating a diff of everything that's allocated in memory right now at this point in time, which wasn't allocated in memory earlier on at this point. And you can even compare between different snapshots. And you can do all sorts of interesting stuff. But at the end of the day, using Tracemalloc, you can get something that looks like this, which tells you for every line of for every bit of memory what allocated that line of that bit of memory. So you can see here, for example, if I just pick up one of the examples here, you can see that in user lib Python 3.4 sysconfig.py on line 411, there's code that allocated 48 kilobytes, which weren't freed. And the nice thing about this is that it kind of collapses together all the different allocations from the same line. So you can see here, there were 2,315 allocations, which all weren't freed. So the total size is 244 kilobytes. And this memory wasn't freed. And then you go and you look at this code and you say, okay, well, should I be freeing the memory that's there? And then you could look at that code and you can see why it's not being freed. So that's the first useful way to troubleshoot memory leaks, is to use something like Tracemalloc. And Tracemalloc is a great library for this. And essentially, this will tell you what code did you allocate and never free. So there's a question here in the chat about memory leaks in Python, and doesn't Python use the garbage collector? So I touched on that a little bit. I don't know if I wasn't clear enough, or if you were joining a little bit later. But there are examples. I gave a little bit of a more complex example. But even though Python is garbage collected, you could be doing something in your application which causes you to not free memory. So for example, maybe you have some global event log variable and you keep on adding different events to that list, then the memory would constantly be going up because somewhere in your code you're holding on a reference to that memory. So it's easy to do stuff like that where you're accidentally allocating extra memory and you're keeping a reference to it somewhere and not freeing it. So the garbage collector won't free this stuff because someone is still holding on a reference to it. Okay, so moving on. Second thing that we can do, which is really a variation on this, of saying, okay, right now, like what stuff is there in memory that wasn't freed, we can do this, as I said earlier, differentially. So you can like start checking, and then you can stop checking. You can say, okay, well, what in that period of time that I was doing this memory profiling, what was allocated and then not freed? And this is a screenshot actually from Robusta, which I work on, Robusta.dev. This is all open source. And here's an example where you run a check on your application for something like 60 seconds. And it shows you here that in those 60 seconds, there was a total of 7.8 megabytes that was allocated and not freed. And then for each place in your code where you're allocating that, for the top 20 locations that allocated memory and didn't free it, then you have details below with a stack trace for each one. So you can see 5 megabytes was allocated at this area in your code, and here's a stack trace. If you scroll down, then you'd see underneath this where the other 2.8 megabytes come from. And what's cool is we're collapsing everything together. So there were actually a whopping, I'm bad if there's no commas, but I think that's 5 million different allocations. So that 9 ran at least 5 million different times. And in total, that allocated 5 megabytes. And you can see that this is the hotspot that you should be looking at, which is allocating memory, not freeing it. Now, the issue that you can sometimes happen with this is sometimes the place that's allocating the memory isn't enough to understand why that memory isn't being freed. So it could be that in one place in your code, you're allocating memory, but you're actually holding on, you're returning that from the function, and then you're passing it to a different function, and then you're putting that in different functions. This object is getting passed along in your code. And then someone takes that and it saves a reference to it, and it keeps that object alive for the garbage collector in a place in your code that's very, very different than the place that it was allocated. So in a case like that, you would see here where it was allocated, but you wouldn't be able to tell just based on where it's allocated who's actually holding on a reference to that. Like imagine you have code. Maybe I can bring up an example here and I can show something. 1 second. It's not going to open. So imagine I have here like some function allocate, and here I do something like return, and I create some massive big string. We'll create a big string with lots of X's. And then I have some other function called like define save reference. And let's see here we have foo equals some list, and then save reference and foo dot append And I'll explain this in 1 second. Now, let's say I do something like this: save reference, allocate. So what I'm doing here is I'm calling allocate. That's returning some huge big string. And then that string I'm passing to save reference. And in save reference, I'm just making sure that that string never gets garbage collected because I'm saving it to a global variable. So if I look at this code and I just use what we looked at before, if I just use this, then I'll see the place that allocated the code, which in this case is this function allocate. But the function allocate isn't the function that's responsible for saving a reference and keeping that alive. So in this case, what I actually want to see is I want to see save reference. I want to understand that this string is never being freed because there's a reference to it in foo. So just seeing where it's allocated wouldn't be enough in that case. So that's where the next capability comes in. And if I look at the next capability, we can see in Python with just 2 lines of code who's keeping memory alive, who has a reference to that memory and is keeping that object alive. And to do that, use an excellent library called object graph. And you just run something like this: object graph.showRefs. You give it a variable, and then it will tell you who is holding on to that variable. And here's example output. I believe the output here actually doesn't match the sample code, but you can generate a graph showing you who is holding on to that. And if anyone here is used to using pprof, Google's profiling tool for the Go language, then this is very, very similar, and it works the same way. So I'll pause for a second to just take any questions from the chat. I see there's a question about Robusta that I'll answer in just 1 second. Okay, so I'll take it first from the second question and then the first. So there's one question about Python primarily relying on reference counting, and can Robusta find leaks caused by reference loops? The answer is yes. You would still be able to see that in both places. You would still be able to see here what line of code allocated it, and you would still be able to see it here. And I believe Python has mechanisms to garbage collect stuff even with reference loops. So you would be able to see that in each place anyway, and see who's holding on to a reference to that from outside the loop. And one thing I just want to emphasize about Robusta is like what we do here, it's really equivalent to this. We're just using Tracemalloc under the hood. So the real question is, can Tracemalloc do it? And if Tracemalloc can do it, then Robusta can do it. What we're doing with Robusta is we're taking different existing troubleshooting capabilities, like excellent profiling tools built into Python itself, and we're just making it easier to run those on Kubernetes. So we're kind of a very thin wrapper there, but really what's doing is Tracemalloc. And then I see if there's a question there, names of any notable projects, companies currently using Robusta. So we don't actually have permission to share any specific name right now on the website from a big company. But if you join our Slack channel, then you can look around and there are some big names. I just don't know if there's someone there who I can share that right now. But you can feel free to join the Robusta Slack community, and we actually have some very big deployments today of Robusta on Kubernetes. Okay, so this was memory leaks, and we spoke about that. And I'd like to move on now to high CPU. And there are really 3 different types of CPU profilers in general. In a CPU profiler, before I talk about the different types, the basics of a CPU profiler is to really stop your code, look at what your code is doing, and then write it down in a notebook on the side. And you do that 1,000 times a second, or you do it and then you do that for 10 seconds. So you end up with something like 10,000 different records in that notebook. And then you look at the notebook and you like put all the records together and you crunch the numbers and you say, okay, well, this line of code is where I was found most often when I stopped the code. So you're essentially stopping your code, checking where it is, writing down where the code is at that exact moment, and then you build a heat map of where your code spends most of its time. So there are really 3 different types of profilers. So a normal profiler, like I said, stops your code, records where you're at. There's an excellent profiler, my personal favorite, called PySpy for Python, which we're actually going to look at later on. And PySpy doesn't stop your code. It has some very cool tricks, so it can profile your application entirely from the outside. And you do that using some various magic. Maybe I'll touch on that in a moment. But you don't stop the code, but you record your code from the outside, and then you give a map of what lines of code we're executing very often. And then the third approach is continuous profilers, where you run a profiler on production all the time, and there's some overhead for that. But the rationale behind that is that the insights you get by constantly profiling will outweigh the overhead of the profiler itself. By seeing that there's a function that's problematic, you'll be able to fix that. And then even if the profiler is adding on 4% overhead, you'll get it fixed by more than 4% if you do continuous profiling. That's the rationale behind that. And whether that's true or not really depends on you and your company and lots of other factors. Okay, so maybe I can say, I didn't prepare anything, but maybe I can say a word about PySpy and how it actually works. Let's say I go to /proc and I can take like an EPID there. I'm just going to take self. That's the bash shell itself that I'm running on. Oh no, I won't do this. Okay, I can't show this. I forgot I'm on a Mac. But you can actually, it's actually fairly easy to read the memory of any Python project, of any Python application, or any application at all for that matter. If you have appropriate permissions, you can read the memory of other applications. And if you do that, then you can actually see exactly what that application is doing at that exact moment if you read the stack's memory. And this is super advanced. Like, you don't need to care about any of this if you use the tool. But that's what PySpy is actually doing. And it's not doing it via /proc. It's doing it in other various methods. So I don't want to go into how PySpy actually works, but it's a very, very cool technique that's worth looking at in detail if you're curious about that type of thing. So we're going to see a demo later on about PySpy. But what I want you to take away from this is that there are different types of CPU profilers. And my personal favorite is PySpy, which you should use. And profilers, CPU profilers, will tell you what your code was doing most often and what the most CPU-intensive areas in your code are. Okay, so let's move on to the third type of issue that we said we would talk about today, which is logical bugs. And this just means your code is doing something that you don't expect it to do. So maybe you don't have high CPU, maybe you're not leaking memory, but you want your code to print 1 and it prints 2. You want your code to handle users and instead disconnects them. And when you debug locally, then you would just connect the debugger. If you're running an application locally and you like in VS Code, you would hit debug and stuff. And then you can stop a breakpoint wherever you want. And there are kind of two issues with doing this on Kubernetes. One, very often you don't actually want to stop the application, because if you stop the application, it's a server, it stops handling requests and gets more complicated. Or Kubernetes will come and kill it because it stops reacting your application. So often you want to stop your application. And so you want to put a breakpoint, but you don't want to stop the application. And two, it can be very hard to set these up and to set up debuggers on Kubernetes. So we're going to look at a solution for that. And I should say the most common non-breaking debugger in the world is Visual Studio Code. And here I am on Microsoft Reactor, but I can say I honestly love VS Code regardless. And it's the IDE that I use very often for my own personal stuff. And VS Code has an excellent, excellent non-breaking debugger. And we will show a demo of that on Kubernetes and how you can use the VS Code non-breaking debugger with any Python application running on Kubernetes, and you don't even need to restart your application. Like if you've been running your application and you started running it yesterday and you never set anything up, you can still do this right now on your application that is already running. So the problem with all these tools on Kubernetes is that these tools are really easy to use if you're doing local development. If you're doing local development, then I'm on a Mac, so I would do something like, I don't know, brew, install PySpy. Yeah, PySpy, and then I have PySpy here, and I do something like that. That would be really convenient. And if I'm using VS Code, let me open up VS Code, and I can just go here and I can do start debugging, and I can run this application and debug it. So that's really convenient. So like here, I'll show that. And I just run this. I would set up the debug remote. Okay. But I could go and I can debug this and set a breakpoint, and I can debug and stop wherever I want and see stuff. So all that in general is really easy to do. But suddenly, when you're running on Kubernetes, then it's not so easy to do because it's not on your local machine anymore, and it's running in different location. And there are different isolation methods so that different applications are actually isolated from one another on Kubernetes. So this has to do with something called PID namespaces. And then there are issues with ptrace permissions. There are all these other issues. And I see that there's a comment in the chat. This is the reason I'm trying to convince to debug using logs, metrics, and not debugging the IDE. The IDE is not available in prod. Yeah, so it's a good point. So I think really the thing to keep in mind, if I go back kind of to the beginning of this talk, then we looked at different issues, and I said there are really two different things you can do here. First is noticing the problem to begin with. So when you notice a problem, you can notice a problem very easily with logs and metrics and stuff, and that's easy to do. But to find the root cause for a logical issue, then it can be very hard to do that sometimes without having debugger or debugger-like capabilities, even in production, because you had to have known in advance what logs you needed. You had to have known in advance what metrics you needed. And if you didn't add those metrics, then you can only gather that data in the next version of your application. And same for memory profiling and CPU profilers. Like you can, if you have logs and metrics and you have all the data there, you can have a metric that says how long it took you to do a specific operation. But if you don't have that metric, or if you have that metric but not for the application that's now going slow, or if you don't even know which operation you have to monitor and check the time on for that operation, then you really do need these stronger tools. Sometimes people call this monitoring versus observability, whereas this is monitoring, noticing the problems, and then looking inside your application in production is observability. So sometimes that's a differentiation that people do. And what I'll try and convince you of today is that you can actually use all of these in production as well. Debugging is the one that I would say be a little more careful with, even if it's a non-breaking debugger. So that you have to decide whether it's right for you or wrong for you. But these CPU profiling and memory profiling and stuff you can actually do in production. And one other thing I should add about Kubernetes, which is very nice, is let's say you run a CPU profiler, you run a memory profiler or debugger in your application, and now you say, okay, well, like maybe my application is now going to behave weird because it was debugged. Well, just kill the pod for your application, and Kubernetes will spin a new pod up. So if you're running on Kubernetes and your pods are replaceable, then it's okay to take one pod to debug that, as long as you're not going to drop traffic for anyone, but to use a non-breaking debugger. And then if you're worried about the after effects of that, then you can just kill that pod and another one will come up. So there are solutions for how you can do that. But it's a very good point. I mean, in general, if you can get away with the stuff here, then you're gathering all that data anyway. You have logs, you have metrics, you all have all that stuff. But sometimes you unfortunately do need the stronger tools here. So I hope that helps address the question from, I think, Fool Snabble, if I'm pronouncing that right. Okay, so the big question, well, I guess I should say first about myself. So I saw a lot of these issues running on Kubernetes myself. Worked at a cybersecurity startup, developed security tools for Kubernetes. Eventually we got acquired, but I saw a lot of these issues myself. And really, me and my co-founder, we wanted a better way to go into get these powerful observability tools. And then we essentially had one of two approaches that we could take. Either we could write like a Python profiler for Kubernetes, and we could write a Python debugger, and we could write memory profilers, and we could do all this tooling ourselves. Or we thought, can we add on a very thin adaptation layer, but a general purpose adaptation layer that's not just for Python, but also for Go and also for other languages, maybe even for databases one day, but a general purpose troubleshooting layer that can take the really good existing tools that exist, whether it's PySpy for CPU issues, or whether it's these different Python libraries for memory leaks, or whether it's a non-breaking debugger like VS Code. Can we take those existing tools and just do an adaptation layer that makes it easier to use them on Kubernetes? And the answer, of course, is yes. And it's also all open source. So let me take a look at that. And very briefly, what we do with Robusta is essentially we want to show you what went wrong for every single issue that can occur, for every issue that can occur in production. And we want to show you everything about what went wrong. So all the alerts, any Kubernetes issues, Kubernetes events, other issues, proactively even tell you, well, this isn't going wrong yet, but it could go wrong. So we want to show you what went wrong, and we want to take a really opinionated stance and saying, okay, not only is this what went wrong, but here's how you fix it. And we add on different automated insights. We look at alerts. If it's an alert that we're familiar with, then we'll tell you how to fix that specific alert. But you can only get to something like 70-80% coverage with automated insights. So we're mapping out all the common Prometheus alerts. We're mapping out all the common Kubernetes issues. We work with your existing monitor stack where they are on top that tells you why stuff happened. But there will always be stuff that we cannot analyze, that we are not familiar with, that's specific to your application. And we know that. So by design, we decided, okay, so let's give you kind of a way to break the glass. Let's give you an emergency switch that you can flip when the insights that we give you about your alerts aren't good enough. let's give you a flip that you can switch to then look inside each microservice and then troubleshoot it yourself using each of the tools that we mentioned previously. So that's what Robusta is, and that's how it ties into this talk. So let me just, here's one example kind of the first part. We show you what went wrong and how to fix it. So if you had a crashing pod, then you can get a message in Slack saying, okay, this pod crashed, and here are the logs for it. So normally you would just get an alert saying there's a bunch of crashing pods, but you wouldn't have the logs available. So here a pod crashes, and then we pulled in the context. We pull in the necessary information like the logs or other stuff. And there are different variations, different ways that you can configure this. We pull in all the context, and then we show that to you in a Slack message with all the data you already need. But then comes the second part of this. Okay, so stuff happens where we can't gather that context automatically. So we want to make it easier for you to troubleshoot. So let me just show you an example of how you do that. So what I'm going to do is I'm going to take a Python application, and I'm going to show you how in about 60 seconds you can run a non-breaking debugger using the VS Code debugger. And you can attach a debugger to your Python application, which is running. Now, I'm doing this on a Python application I have running in my own cluster. So let's just run here kubectl get pods. And I will bring up the source code for this as well. Something's not hangs, I'm not sure why. Yeah, fix that. Okay, well, let me show the source code. So the source code is really simple. It's this really simple application. It just prints starting up, then it has an infinite loop where it sleeps for a bit and then prints a message. So very simple application, but that's enough for us to show how you can troubleshoot stuff and how you can debug that. Okay, so if I go back to over here, then here's this pod Python debug me, and that's running that code. And I did no setup on this in advance. It just is running, and we're going to debug this in the VS Code debugger without stopping this, without restarting it, without impacting it in any way. And I have to say this is good for people like me because I always forget to set stuff up. And if I had set stuff up in advance, I'd never be able to troubleshoot anything. So let me copy paste. So what I'm going to do is I'm going to run one command, and I'm going to essentially start an automated Robusta troubleshooting action. So I just type here Robusta playbooks trigger, and then I give it the name of what I want to trigger. So Robusta playbooks trigger Python debugger. That's the automated troubleshooting action that we're using, and I just copy pasted that from the docs. So you can see here there are different actions available. So I can run a CPU profiler, I can do the memory profiling, I can do all these different actions. These are the Python troubleshooting actions. They're ones for Java 2. They're ones related to all sorts of other events that can occur in your cluster. But we're just looking at the Python ones today. So I can run here Robusta playbooks trigger Python debugger, and then I just have to give it the name of the pod. So let me copy paste this Python debugging me pod, and I will hit enter. And if you want a user interface for this, we'll actually have that in a week or two as part of our SaaS platform. So you won't even have to copy paste the commands. Okay, so this is running. And what's going to happen behind the scenes is we're setting up another pod running on the same node. If you're familiar with ephemeral containers in Kubernetes, and it's very similar, but we're doing it in a way that supports older Kubernetes versions as well. And we're setting up another pod, and we're just launching the Visual Studio Code debugger there. And then we're going to do all the magic and all the Kubernetes stuff. So all you have to care about is just you ran this one command, and now you get instructions for connecting VS Code. Okay, so it says done, see instructions for connecting to the debugger in Slack with a Robusta UI. So I'll just jump over to Slack because we want to focus on open source parts. And essentially, I need a connection from my local machine into the cluster. So there are different ways we could do that. Like we could do some solutions part of Robusta where we set that up for you, but then we have to deal with the security. So instead, we just put the security concern on you. So you have to somehow port forward. So the easiest way to do that, if you have a kubeconfig for the cluster, is I can just run port forward. So I'm just port forwarding to that pod in the cluster. And now I've port forwarded, and now all I have to do is go to VS Code, do a remote attach to localhost, and port 5678. So let's go and do that. I can go here, and here I will go run, start debugging. Now, unfortunately, it's actually going to remember all the details, which I don't want. I want it to be a little harder to set up on purpose. So let me see. I want to delete my debug configuration so I can show you how to do it from scratch. It just remembers it because I did it in a previous demo. Okay, here we go. So for the debug configuration, I just choose here remote attach. We're going to connect to a remote process. So we'll take localhost because I'm port forwarding. Here's the port that I'm port forwarding into the cluster. And just like that, oh wait, I have to click the green button. Okay, so just like that, I'm now connected to this pod running in the cluster. So I can see on the bottom in standard out, I can see all the output that pod is printing. Now, what I could do is I could click here and this would put a breakpoint, but then this pod would stop responding. It would stop responding to traffic. I would pause at least one of this pod's threads. So I said non-breaking. What I mean by that is I'm going to do something similar, but we're going to let the pod keep on running. So I can here add what's called in Visual Studio Code a log point. I'll do here add log point, and we will print this does not stop your code. But we, of course, want to debug something. So I have to be able to print something from the code. So I will put in here I. I is a variable in the code. And we will print this does not stop your code I. And you can see here now that it says this does not stop your code I. So I could troubleshoot anything I wanted this way. I could print out different variables. I could troubleshoot wherever I want. And this would not stop my code that's running in the cluster. So this is a really great feature. And I wish I could take credit for it as a Robusta feature, but of course I can't. Like I said, it's just VS Code. And props to the VS Code team for really making something that is so easy to use. And what we're doing with Robusta is we're just doing the setup. We're making it easy to use on Kubernetes by triggering this automated workflow. So you just trigger this automated workflow, the Python debugger workflow, and then it sets up the debugger and launches it for you. Now, let me show you another example using a CPU profiler. So we're going to trigger an automated workflow just like before. But this time, instead of triggering the Python debugger workflow, I will trigger the workflow for the CPU profiler. So that is just called Python profiler. So I will run Robusta playbooks trigger Python _profiler. And it could now get a CPU profiler profile on the same application. But I'm actually going to do something a little different. Robusta itself is written in Python. So let me CPU profile Robusta because that will be more interesting output. Okay, so I'm running, what did I do? Whoops, it needs to be pod name, I think. Oh, my bad. That should be name equals pod name. Okay, sorry. This is what happens when I try not to copy paste. Okay, so what this is doing now is it's running this automated action. And if I go back over here, then there are various configurations that I can take from this automated action. I can give it. For example, I can say how many seconds to profile for. There are multiple processes. Which one? Should we include idle threads? And these are really all just from PySpy. So we're just exposing the PySpy parameters. And the other thing that you can do in Robusta is you can set this up to trigger automatically in various circumstances. For example, I could define that whenever there's a Prometheus alert for high CPU, then this profiling action will be automatically triggered. Robusta will use this profiling action to gather the relevant context on why I have high CPU, on why I have high memory, and why I have a memory leak. And then, sorry, this is CPU in this case. It will gather the extra data on why I have high CPU. And then when I get that alert, whether I get that alert in Slack or in Ops Genie or in some other system, then that alert will already contain details that are actionable that you can give to the developer to then go and say, okay, why is there high CPU? What do I need to do to fix this? And like I said, this ties into our broader vision of telling you for every alert how you can fix it and why it happens to make every alert actionable. Okay, so I got this message in Slack, and it could be MS Teams as well. It could be any destination that we know how to send data to from Robusta. And if I just click here, I can see here a graph. The colors actually don't mean anything. They're just here to add contrast. And this is a type of graph which is called a flame graph. And you have to learn a little bit how to read these. But essentially, each line here, the width of it says how much CPU it was using. And again, the colors mean nothing. So I can see that all the CPU that was being used is in functions which were called from this threading.py function. That will always be there because that runs whenever you start up a new thread. And then in that, half of the CPU was used up by Sentry. Half of the CPU was used up by this other function. If I drill down to the Sentry area, then half of it, sorry, about a third of it or a fifth of it was used up by this. The rest was used up by this function. And the further down you go, the further down you're going in the stack trace. So everything here, this function was called by this function, which was called by that function, and so on. And I can also open up an interactive version of this. And then I can also filter and I can do different stuff. So I see a comment, and this is kind of like the disk optimizer in Linux. And yeah, it's very similar. We actually want to add on to Robusta this exact thing for disk as well, with a similar type of visualization. So then let's say you get an alert for low disk usage, that one of your nodes is running out of disk space, one of your pods or whatever, then you can see the exact same thing. And you can get that information you then need to make this actionable. Okay, well, which files are using up the space? So what we're doing with Robusta is we're building this framework. We can gather all this extra data when different errors occur, but you can also automate the whole process. So either you troubleshoot manually or you gather the data automatically. But whichever way you're gathering it, then you get this nice visualization alongside the alert. So whenever an alert arrives in Stack, then you always have the extra context. So we're here to elaborate on that. Here's an example. We had a crashing pod. So for the crashing pod, here's the full stack trace. And the same is true for other cases. We can send graphs and we can send all this other data. Okay, so let's get back to the slides for a moment. I think that's it for the live demo over here. Let me just open up my slides. Okay, so I gave two examples. First is a non-breaking debugger and how you can run that with Robusta. And again, what we're really doing here in Robusta is we're just wrapping the really good existing tools that are out there. So when you're running this, there is no Robusta debugger. We're just wrapping the VS Code debugger. When you run the CPU profiler, there is no Robusta CPU profiler. Really, we're just wrapping PySpy, which is an incredible CPU profiler. And the problem that we're trying to solve with that is we have something like 50 years of really great troubleshooting tools for Linux and for all these different issues that occur. And for optimizing databases and seeing which indexes you need, seeing what's using up disk space. We have all these great tools, but suddenly on Kubernetes, it's non-trivial to run those or to run those at the right time in the right way. And that's where Robusta comes into the picture. It's doing the orchestration to help make running these troubleshooting tools easier. And just a word about our SaaS platform. So we also have a SaaS platform which shows all the same data. And in about a week, you'll be able to click on the button there as well if you want to start troubleshooting something on demand. But I'm not going to talk about that today. That's also not open source. And we used to tell people that it took 60 seconds to install the open source. And then this happened.
You can come here. So Robusta has these 60 seconds install auto. So let's put it to the test. Okay, I was doing another test before.
Okay, so it doesn't take us 60 seconds. And really, a huge thank you also to Nuno Ducarmo, who created an excellent video about Robusta and brought it to our attention. So we've had to update the website because it doesn't take 60 seconds. So we've updated our website to represent that. It is a 97.68 second install, according to the last time someone measured on YouTube. And if you beat that number, by the way, then we will send you swag. So if someone beats that number and can do an install, and I think you have to get under like 90 seconds. But if you get under 90 seconds, then we'll update the number and we'll send you some swag for that. And we are really easy to install. If you already have Kubernetes, then this is great and easy to use. If you don't have Kubernetes, just use all the existing tools in here that are non-Robusta specific. So you can, if I go back, then you can use Object Graph to get the different graphs. You can troubleshoot the memory leaks with Tracemalloc. You can use PySpy for the CPU usage. You will be able to get all of that without Robusta as well. Like I said, we're really not inventing the wheel. We're just taking these existing tools and adapting them. So if you don't use Kubernetes, then please feel free, go ahead and use these without Robusta. If you are on Kubernetes, then we make it really easy to adapt all these existing tools. If you already have a troubleshooting stack set up, whether it's with Azure, something that's Azure native, or if you have something set up with Prometheus and Grafana, then you can just send your existing data to us, and then we'll take your existing alerts, and we'll add on all this extra context or make it easy to troubleshoot stuff manually. You don't have to send your alerts if you just want the manual troubleshooting. So you do a quick install on your cluster, and then you will get all the data. And if you are new to Kubernetes and you're setting up your first monitoring stack, then we highly recommend that you do the all-in-one install. So you can do an all-in-one install. When you install Robusta, you install Prometheus, you install Grafana, you install all these components together as an all-in-one package. And we've tried really hard to set it up so that the default alerts and the defaults that you get are really good. And out of the box, will make it really easy to troubleshoot anything that goes wrong. So I want to address one question that I got from Reddit in advance. Since I'm a newbie with Python and only slightly less so with Kubernetes, what are the best beginner tips for troubleshooting pods, things rookies may overlook? And my advice is look at Kubernetes events. So I can go here, and on any Kubernetes cluster, I can run kubectl get events. And this will fetch a special type of object from the Kubernetes API server, which are the events objects. And these events objects store data about different errors and different events that happen in the cluster. And these are essential when you want to troubleshoot stuff, not specific to your Python application where we just looked at the different tools for that, but issues like a pod crashing or issues like a pod running out of memory or a pod being pending and so on. So the formatting is a little bit off because I make my screen very big for demos. But you can see here all these different Kubernetes events. And if you want to see a prettier version of that, then we also send that to our SaaS platform. So here's the way it looks. And if I zoom in here, let me zoom in a little bit on this image. Let me see if I can zoom in on this. Okay, I'm having some difficulty. But if you zoom in on this image, then here's a case where there was a pod that failed scheduling. And it failed scheduling because 0 out of 4 nodes were available. And then we will bring in Kubernetes events. And you would see the exact same with kubectl get events, just formatted a little bit differently. So you can see that 0 nodes are available because 1 has insufficient memory, 1 is unschedulable, 2 have some other conflict with node affinities. So Kubernetes events and running kubectl get events is the #1 thing that I recommend when you have an issue with Kubernetes that's not application specific, like what we looked at. Okay, so I'm going to stop for any more questions. And I see there's one question here, not programming related, but I was wondering what got Natan into programming. Is there anywhere we can read his history? Also, does he have any tips for first-time Robusta users? Okay, so I got into programming because I was lucky, and I was born to a family where my dad himself was a programmer. So he got me into programming at a young age with this, I forget what it was called, Micro Worlds maybe, where you programmed and taught turtles how to make different shapes on the screen. We would program a turtle and then it would like walk around on the screen and leave a line behind it. So you could program it to make different shapes. So I got started young, but what really gave me a boost, and which is an easier way if you didn't happen to be lucky and be born to a dad who was a programmer at a young age, showed you that, is I got involved in open source when I was in high school via a Google program called GHAP. They've changed the name a bunch of times, but it was a program for high school students to get involved in open source. And we, to try and give back to the community, we also trying to build an open source community that's really easy for people to get involved in. So if you want to get involved in open source projects, honestly, it's a great way to really advance your career and to learn a lot. And you can join our Slack channel and reach out to us, and we will try and help you get involved in the community, whether it's contributing just with documentation, or if you want to try and write a playbook or an automation action, or if you want to try and write some code, we will try and help out and answer questions. And tips for first-time Robusta users, I would say that it is worth for first-time Robusta users, just get started and try it out. I think that would be really useful for you, and then give us feedback. We'd love to hear from people. If something didn't work the way you expected, then you can open an issue on GitHub, or you can tell us something else. And just get started and try it out. That's my #1 piece of advice for anything in life. You have to try it and learn by doing. And there's a comment there about the guideline videos in English, which I absolutely agree with. I know I feel that way when I watch videos. Another comment about how hard it is to get into open source. I always don't feel good enough to help. Nonsense. Just do it. And start with small contributions. Challenge yourself. The only thing that can happen is like maybe you'll feel bad if you try something you don't succeed, which probably won't happen anyway. But you can never learn, you can never grow if you're not willing to put yourself in that situation where you're challenging yourself and you're trying something that's difficult that you haven't done before. And it's really not that hard anyway. But a good way to get started with that, I can add on to be a little more specific, is we have on GitHub, for example, a whole bunch of different issues. And if you go to GitHub, then you can see here in the issues, we have a bunch of issues that we tag with like good first issue, or we have a bunch of those. So that's a good place to come. And then you can try out, pick an issue on GitHub that looks like it's something you would approximately be interested in learning, and then stop by the Slack channel and say, I want to work on this. Do you have any tips? How can I get started? And we'll help you out. And Fool Snabble has a comment here, when it feels awkward is when you are learning, which I absolutely agree with. If you don't feel awkward and you don't feel a little weird, then you're not learning. And I myself always have jitters a little bit before a presentation like this. And I'll watch afterwards and I'll notice all the places where I said or I said like a bunch of times, and you get better over time, I suppose, or you don't. But you kind of have to put yourself in that scenario in order to learn and grow. Okay, one more question from Nadav. When I run the Robusta command, what is happening? So I actually have a bonus slide on that. And let me show you that. So if I go back, I'm going to go back just a moment. And we're going to look at the examples here. So I'm running Robusta playbooks trigger Python debugger. Here's the name of a Robusta action. Robusta playbooks trigger Python profiler. And there are automated variants on this as well. So you can like run a Python profiler. You can fetch the logs automatically when a pod crashes or when there's a Prometheus threat. So these are all the same. In every single case, there's some Robusta action, whether it's fetch logs or Python profiler or the VS Code debugger, Python debugger, or the memory profiler. There's always some like word here, Python debugger, with an underscore in it. And the secret is that these are just Python functions. So if I jump over to the code, then here is the code for this Python debugger. And this is just a Python function, which gets a pod event as input. And here you can access the pod. You can run commands on that pod. You can pod's YAML fields, the name, the namespace, the metadata, whatever you want. I could restart that pod if I want. I forget the command to do that. But I could access that pod, and I could, what else could I do here? That's interesting. I could get processes on that pod with an easy function. So there are all these different functions here that we give with the Robusta API to access that pod. And essentially what we're doing here with the Python debugger is we're just doing something like that event that got pod and exec and debugger pod. And that will launch another special debugger pod on the same node, kind of like ephemeral containers. And then in that other pod, we just run the VS Code debugger. It's a little more complicated than I in practice, but that's the gist of it. And let's say I wanted to go now and add on support for Go so that you can run pprof. Then to do that, I would do an action like action pprof Golang. Maybe I'll get a different time, but let's say for some weird reason, just not everyone is familiar with pprof. So let's say you wanted to run the ls command on certain scenarios. Then you could do it like this. So I could just do it here like event.getPod.exec, and I could run the ls command. I could get the output. I could do output.add enrichment, and I could save here or do like a file block. And I could just save that output, and then that would automatically arrive in Slack or whatever other destinations you configured. So it's really easy to extend these and to add these on, and we get some of these from the open source community as well, and we're always adding on new actions. So each of these actions I did, these thin adaptation layers, they're really just Python functions. And that makes it really easy to add more of these on. Are there any other questions before we wrap this up? Okay, so a few more things I'll just say. We also have a channel on YouTube for Robusta, and I put a lot of Kubernetes videos there. And lastly, at the moment in Robusta, we're doing a lot of user interviews, and we're interviewing people to really hear about how they use Kubernetes and how they monitor it and how they troubleshoot different Python and Kubernetes problems. So if you are running on Kubernetes and there are at least 100 people in your company, then we would really like to talk to you. We've spoken to a lot of smaller companies, and we'd love to talk to bigger companies as well. So please send me a message on LinkedIn on our Slack community. You can email Natan@Robusta.dev as well. You can contact me anyway, reach me on Twitter. But we would love to do a user interview with you and just ask you a few questions. It takes about 20 minutes. And we'll send you some awesome Kubernetes t-shirts afterwards. We have t-shirts that say kubectl, get sleep. So if you work at a company with over 100 people and use Kubernetes, we would absolutely love to speak to you. And it could really help us improve the open source project. Thank you, everyone, for your time. And thank you for interacting with me in the chat. It means a lot because I hate it when I jump on the presentation and then you never get any feedback or comments and you don't know if anyone is even listening. So that's always a nice experience. So thank you to everyone for participating, asking questions. And I hope to see you all again in future sessions.
Indeed, thank you. Thank you guys for being so active in the chat. And thank you, Natan, for being and giving us this presentation today. It's been a pleasure to listen. And I think, yeah, the chat itself tells how it went. It was really, really great. And everybody enjoyed it very much. So with that said, I just want to say one more time, a big thank you for being at this Microsoft React workshop with us and showing some stuff to our audience.
It's my pleasure. Thank you so much for organizing it and for giving me the opportunity to be here.
Yeah, it's been a pleasure and looking forward to seeing you here again with us. Thank you.
Anytime you want, I'm available. Take care. Thank you, everyone.
Take you up on that.
Bye. Oh, I will. Bye.